So in this episode of Science for the Non-Scientist, I'm going to talk about why the Delta variant of coronavirus is so dangerous. So first, what is this Delta variant? Well, remember that the original virus, the coronavirus, emerged in China in December of 2019. Now, this virus since then has been mutating. Most viruses do. And there are four mutations that have scientists especially concerned. These are known as the alpha, beta, delta, and gamma mutations. The alpha mutation, also known as B.1.1.7, emerged in the UK in September of 2020. The beta variant had emerged slightly earlier in May of 2020 in South Africa. The Delta variant emerged in India in October of 2020, and the Gamma variant emerged in Brazil in November of 2020. Now, why are these variants so concerning? Well, it turns out that the Alpha variant is 50% more transmissible than the original coronavirus. This means that it is 50% easier for this virus to spread within a population. And it turns out that the Delta variant is even 50% more transmissible than the Alpha variant. So this translates to being more than twice as likely to spread than the original coronavirus. And unfortunately, this Delta variant is spreading quickly throughout many countries of the world. What makes this Delta variant so infectious? The short answer is we don't know the full story, but there are a couple of ideas that we think are likely. So they both have to do with the spike protein, which is this protein that covers the entire virus and is essential for the virus to get inside of our cells. We think that the mutations in the spike protein in this Delta variant make it easier for the coronavirus to enter our cells. Once they enter our cells, of course, they can start an infection. Second, we think that the mutations in the spike protein in this Delta variant make it harder for antibodies to attach to the coronavirus and neutralize it. So here's an example. This is the original coronavirus with the original spike proteins. Now, our bodies make antibodies to the spike protein either as a result of natural infection or because we've been vaccinated. If this spike protein undergoes a mutation and changes its shape, then the antibodies we've previously formed don't work so well against it anymore, and they can't effectively neutralize the coronavirus. The question arises, do the vaccines we have still work against this Delta variant? Fortunately, it seems that the Pfizer, Moderna, and AstraZeneca vaccines still seem to protect people against severe illness from the Delta variant. This means that people can still get sick from coronavirus, but hopefully they won't become hospitalized. It's the unvaccinated people, unfortunately, that are more likely to be hospitalized if they get the Delta variant than if they were to have gotten the original strain. And you can still get the Delta variant even if you've already had another strain of COVID-19. And this is why health experts recommend getting the vaccine even if you've already had COVID naturally. The last point here is that the larger the unvaccinated population in the world, the more likely it is that the virus will continue evolving into more dangerous strains. And in the future, some of these strains may not be able to be stopped by the vaccine. The reason that this occurs is that the more people there are that are not vaccinated, the more opportunities the virus has to mutate, and some of these mutations can lead to more deadly strains. So in this graph provided by Johns Hopkins, you can see that the coronavirus cases are still growing in many parts of the world, with the highest numbers occurring in the US, India, and Brazil. So as long as coronavirus continues to grow throughout the world, or rather the number of people that are infected by coronavirus continues to increase throughout the world, the virus will continue to have opportunities to mutate into more dangerous strains. Thank you for joining me, and I'll see you next time.